Hi guys, this is the day 40 of our programming class. So the strings concept whatever you have learned till now is more than enough, but it is not completed yet. Okay, so we have to complete the arrays because there are some string questions which are interrelated with arrays. So I have to complete arrays also, then again I can come back to the strings. Okay, so for meanwhile strings is completed, almost completed. I can say around 90% is completed. So now before going to the arrays, let's talk about complexity of a program. Okay, efficiency of a program. Let's talk about that. So normally when people tell reduce the lines of code, so they are telling reduce the complexity of the code. The complexity of the code is actually a broad perspective. Okay, there is no clear definition what's the meaning of complexity, because if there is 1,000 lines of code, that's also a complexity, right? If a program of 100 lines, if I write for 1,000 line, which it means that it is a complex program, right? Yes. So we have to reduce the complexity of a program. It might mean something like this. It might mean that they want you to reduce that 1,000 line to 100 line. That also might be the case, right? How to do that? For example, you should know the inbuilt methods. For example, if someone tells reverse a string, sometimes you might write for loop I equal to 0, I start from like that. You will try to reverse. That code will take 6 lines of code, but you can write sb.reverse 2 lines of code, right? Yeah, so you should know the inbuilt method. In that way you can reduce the number of lines. One way is to reduce the number of lines. That is how you can decide which code is more efficient, but that doesn't stop there. There is one more way to mark a program. If you want to give a marks for a program out of 100, how much marks you want to give, then not only number of lines but how much time it takes to execute also you have to see, which means now comes the time complexity. I'll talk about that, don't worry. So what is this time complexity? Time complexity means it is used to measure the efficiency of a program with respect to how much time it takes to execute the program. Okay, so if there is a program which executes for 1 second and your program is executing for 10 seconds, like if it takes time to generate the output and if it takes the time as 10 seconds, then your code is not efficient and his code is efficient. Okay, so comes then there is a time complexity, then there is a space complexity. What is the space complexity? It means when your program is running, how much extra memory is it taking to evaluate the expressions. Okay, how much extra memory, how much variables you are creating, are you creating necessary variables or unnecessary variables? All these kind of things comes under space complexity. We will see about that. So what I want you to understand is, don't worry. Okay, this time and space, you just understand the basics, that's enough for us. We don't have to see the formula of how it is generated and all. It is not at all required. Why? Because when you are in a competitive programming, when you are solving hacker rank, no one will ask you a derive for n log n time. No, they will not ask you that. Okay, you should know as a programmer, should I use this logic or this logic? Now how do you decide, right? You as a programmer, you should have the ability to think, to choose between two different logic, because when you are looking at a question, you will be getting 5 to 6 logics, but which logic to approach, you have to understand. Why? Because I think you already seen some of the test cases will fail. Why? Maybe because it takes more number of times. If it takes more time, let's say more second to execute, you have to understand why it is taking more second to execute. Okay, so you will get to know today. So when you get to know the time complexity, as soon as you look at the code, you should understand what is the time complexity of that program. When you understand what's the time complexity of the program, then only you can decide, should I go with this flow or this flow. I hope it is clear. Okay, see, it is not like randomly you have two logic. You should not do like this, inky pinky ponky, father had a donkey. So you should not do like that, right? You should have a basis. On what basis did you choose this logic? You should be ready to explain. Yes, because this logic is better than that logic. Why? Because this time efficiency is very good, means it is taking less amount of time. How? You should be able to tell. I'll tell that how. So I hope you have understood. That's why time efficiency, understanding this, time complexity is very, very important as a competitive programmer. I'm not talking about if you are going for an interview, simply they will tell reverse a string. You can do it in any way, they will select you. But competitive programmer means there are other programmers along with you. Your program should be more efficient. That's the meaning of competitive program. So in that case, you should be ready to explain them why it is more efficient. Okay. Yes. So let's see here. Let's take a basic program and let's try to understand each and every terminologies here. Okay. 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 So let me write a for loop. Let me write a for loop with a black colored pen. Okay. For loop. Here I will write int I is equals to 0. Okay. Let me write I is less than 5. I plus plus. I have written like this. And imagine that there is system.out.print. There is what? Hi. Okay. I am printing what? Hi. So my question is, how many times this for loop will execute? How many times this for loop will execute? 5 times, right? 5 times. If I write this as 8, this for loop will execute 8 times. And if I make this as n, this for loop will execute for how many times? It will execute for n times. Is it clear? It executes for n times. So if I write like this, so it executes how many times? N times. Okay. Yes. If it executes for n times, it doesn't mean time complexity is n. Okay. I'll tell you. Watch here. Now, as of now, if you see n here, what you have to write? This is the number of times it will execute. But when you are talking about time complexity, you have to tell with the big O notation. Okay. You have to tell like this. The order of n. You have to tell. Okay. Order of n. Okay, order of n. I know here some confusion will be there. Let me tell one more example for you. Okay, let me tell one more example. Now, I'll write one more for loop. Okay, I'll write here one more for loop where int I is starting from 0, I is less than n by 2 I will tell, not n by 2, I plus plus. Okay, and here I told system.out.print, again I will tell the same thing, hi. Now, how many times this program will execute? This program will execute, it will execute for how many times? Not n time, but n by 2 times. Yes, it will execute n by 2 times. Does it mean that its time complexity is n by 2? No, this is what I wanted to tell you. Its time complexity is not n by 2. Okay, what it is then? I'll tell you. Is the order of n only. Is order of n only. How? How means you have to split this n by 2 as half into n. Is it clear? Don't you think n by 2 means half into n? Yes. Now, whatever half, that is called in the maths, that is called as coefficient. That coefficient you have to ignore. You have to ignore whatever number is there, you have to ignore. If you ignore that number, what else is remaining? N is remaining. You have to write that n. Is it clear? So here both of them are in the order of n only. So what I want you to do is, you take the heading as time. Okay, you take the heading as time complexity and write this program. Okay, write this program, write these two programs. I will be telling other programs also. I want you to pause the screen and take the notes of this. Okay, so let me go to the next slide. Okay, so here let me give one more example, right? That is, let's imagine that there is a for loop where int I should start from 0, I is less than n, I plus plus. And here there is some statement are there. I will not write SOP also, because I want you to imagine that there is SOP. Okay. So next there is now watch here. This for loop is opened and this for loop is closed, right? For loop is opened here and closed here. Okay. And below this for loop, not inside this for loop, below this for loop, I will write one more for loop. Okay. I will write one more for loop. Int I equals 0, I is less than n, I plus plus I will tell, I plus plus. Okay. Let me write here system.out.print, let me write hi. Okay. And here system.out.print, let me write what? Bye. Okay, let me write hi and let me write bye. Okay, and this is one more for loop. As you can see, two for loops are not inside each other, they are outside of each other, right? Now you tell me what will be the output, right? Don't you think n times first hi will be printed, then n times by will be printed. Yes or no? So tell me, how many times the output will come? Is it n plus n times output will come, or n into n times output will come? What it is? There is only 10, if n value is 5, don't think there will be only 10 output, because 5 times your high will be printed, and when your n value is 5 times your by will be printed. So it is n plus n times your program will execute. Is it clear? This for loop will execute for how many times? N times. It will execute for n times. After that completely executes, then the control will come below, and this also executes for how many times? N times. Okay. So we have n plus n, not n into n. Okay, why it is not? For that you should take one example. If you have confusion, you take one example, like n value is 3 or 5. If n value is 5, how many output you will get? You will get only 10 output. Why? Because 5 times your high will execute and 5 times your by will execute, right? If it was one for loop inside another for loop, then you know it is 5 into 5 will happen. I hope you remember the star pattern, right? Star pattern. Yes. In the star patterns, we have how many stars we have printed? 25 stars we have printed, right? Totally. Yes. So that you will get when you write for loop inside a for loop, but we have outside here. Okay. So it is what it is. I'll tell you. So here, how many times it executes? If I write executes, okay, it will execute n plus n times. That is same as 2n, right? 2n times. Yes, this much you understood? Yes, it executes this much time. But this is not called as the time complexity of a program. If you want to tell time complexity of a program, first you have to represent with the order, okay? Order of what? 2n, order of 2n. We have to reduce it, and finally it will become order of n only. Is it clear? Order of n. Why? Why? Because the coefficients we have to ignore. Whatever number is there, we have to ignore those numbers. So it is like this. I hope it is clear. Please take a notes of this also. Okay. Okay. So next, let me extend this, right? Let me extend this. Let's imagine 2 for loops I have here. Then I have one more for loop where int I should start from 0, I is less than n by 2, I plus plus, right? And here let me write system.out.print. I'll tell hi. So totally how many times this will execute? N times, and this will execute n by 2 times, So if I'm talking about order, okay, it is n plus n by 2. Okay, that is same as order of 2n plus n by 2, right? Because n plus n is 2n, and this is same as order of, okay, 4n plus n, that is 5n by 2. Okay, which is same as order of n only, because 5 by 2 is a coefficient. You have to ignore the coefficient and it becomes order of n. Is this point clear? Okay, is this point clear? Now, right, let's clear this. Okay, let's clear this. If I write for loop, okay, int I is equal to 0, I is less than n, I plus plus, okay, if I write I plus plus, and there is some statement. What is the time complexity here? Time complexity is order of n, right? Order of n. Now what does it mean? Okay, it means that when your n value changes, the time complexity also will change. Is it clear? When your n value changes, if your n value is 10, the time complexity is 10, right? When your n value is, your program will run for 10 times. When your n value is 50, the program will run for 50 times. When your n value is 1000, the program will run for 1000 times. When your n value is 1 crore, the program will run for 1 crore times. Don't you think there is a direct relation with the input, right, and how many times it executes? Agree or not? There is a direct relation with the input and how many times it executes. There is a direct relation. Whenever there is a direct relation, we represent it in the order of n or n square, we will see. Okay, why I am telling this is because like this, watch here. Imagine I have taken from the user, int n is equals to from the user's input I have taken. Okay, user input I have taken. So I have written like this. Now let me write one more table, right, one more column here, where yes, I am taking input from the user. Int n is equals to user's input I will take. I have taken the user's input. But in the for loop, okay, what am I doing in the for loop? Watch here. In the for loop, okay, in the for loop, I'll write int I should start from 0, int I should be less than 100. I'll tell I should be less than 100, I plus plus. Okay, and here I'll tell okay. Now you tell me, right? You think here. If my user enters any value, right? If my user enters any value, will it affect my for loop? You think and tell me, will it affect my for loop? No, because my for loop is not going according to n, it is going according to 100. It is going according to 100. Don't think 100 is a bad number. No, 100 is not too much. I am not taking whether, whether this is good or not. I am talking about when your input changes, how your program's running execution time, it will change. That's what is here. Okay, that is what is here. So imagine if n value is 1, tell me for loop will execute for how many times? Here for loop will execute for 100 times only. Your n value is 10, for loop will execute for 100 times only, because the condition is I is less than 100. User input is 100, for loop will run for 100 times. User's input is 1 crore, for loop will execute for 100 times only. Input is 1 million, 10 million, 100 million, 1000 million, 10,000 million, right? Whatever it is, the for loop will still execute for 100 times only. Now, don't you think this is a constant value, right? Like whatever input you give, it has no relation with the program's execution time, right? Agree or not? See, I gave 1 trillion also. If I give 1 trillion, will it have in the second program, not the first program, will it have the running time problem here? No. Why? Because n value is 1 trillion, no problem. But for loop will execute for 100 times only, right? Since there is no relation with the n value, okay, or you should not think like that. What you have to think is, you have to think like this. Whatever the input is there, this program will take a constant time, right? This program will take constant time. Constant time, okay? That how it is represented? The constant time is represented with the order of 1. Whenever you see order of 1, it means that it doesn't mean it is taking 1 millisecond to execute. No, 1 is not a second there. 1 represents constant time. That can be 100 or 10,000 or even 1 crore, okay, even 1 crore. But it will take constant time only, okay. For example, let's imagine I had written here, right, I had written I is less than 1 crore. I had written 1 crore, I plus plus. Yes, executing for 1 crore time is bad, I agree. It will take a lot of time, I agree. If it takes 1 day to finish also, that doesn't change my definition of time complexity here, okay. The definition of time complexity is like this. According to the input, how your execution time will change, that's it. So when you are talking like this, if the n value is 5, the time complexity is order of 5, then it is called as a linear time complexity, okay. Linear time complexity means, as we have seen in the left side, right, here can you see it is a linear time complexity. If n value is 100, your for loop will execute for 100 times, right. If your n value is 1000, your for loop will execute for 1000 times. It's a straight line, so it is called as a linear time complexity. Is it clear? And this is called as a constant time complexity. Why? Whatever your n value is, your for loop will execute for 1 crore times. 1 crore time is bad, I agree, but it's a constant after all, right? It is a constant, you give n value 5, for loop will execute for 1 crore time. You give n value 10, for loop will execute for 1 crore time only. So it's a constant value. That's it, okay, that's it. So I can tell here it is order of 1, okay. So I want you to take a notes of this, okay, take a notes. Pause the screen, take a notes. That's all you have to understand here, okay. As a programmer, this is all you have to understand. Then let me write one program here, right. Let me write one program. I'll write for loop. Int I should start from 0. I is less than n I plus plus, okay. I'll write a for loop, not here, okay. Then after this I'll write one more for loop, not inside, outside. Int I should start from 0, but I should be less than, not m, not n, I'll write m here, okay, I plus plus, okay, fine, okay. Now definitely our n value and m value can be different, n value can be 5, m value can be 1 crore, right? Yes, we can't imagine n and m value to be exact same. So what do you have to do? So we have to first think, right, that how many times it takes to execute this. It takes n times, right? It takes n times, and for this it takes m times, m times. So now what I should do? I should think, okay, it is order of n plus m, order of n plus m. I have to write this much. Now can I reduce this? No, don't write order of n. This, this is our time complexity here, order of n plus m, okay, n plus m. It will take n amount of time plus it will take m amount of time, that's it. So this is how to represent when you have two different or three different variables. This is how to do order of n plus m plus k plus j. That also, if there are many loops with the different variables, then you can do that. Okay, so this is how it is. I hope you have understood this also. So let me give one more thing. Let me undo this. Let me extend this a little, right? Okay. So I'll write here one more for loop where int I should start from 0, I is less than n only. I will write I plus plus, okay, I plus plus. So if I write like this, you think and tell me how many times this for loop will execute. The last for loop will execute for n times again, right, n times. Okay, so now if I am writing the time complexity of them, so it is order of n plus m plus n, which can be written as order of 2n plus m, right, because n and n combines here, 2n plus m. Now since there is a coefficient here, I have to ignore that. So it is the order of n plus m only, because 2, that number is gone, we have to tell order of n plus m. Okay, so you can take this notes also, take this notes. Okay, so I hope you have understood somewhat here. Okay, somewhat about time complexity you have understood. Okay, okay, now so let me write one for loop, right? Okay, for loop, okay, where int I should start from 0, I is less than n, I plus plus. Inside this for loop, right? Inside this for loop, I'll be writing one more for loop. Okay, maybe with a different color here. So one more for loop with int j should start from 0 and j is less than n only. Okay, j plus plus. Yes. So if I write like this, remember this is the same program as star patterns. And tell me one thing, in the star pattern, when my n value was 5, how many total stars, were printed? The stars are printed 25 times, right? Star 5 times, again 5 times, 5, like that 5 into 5 happened. 5 row into 5 column, 5 into 5. So it is n into n time complexity here. Okay, so this whole thing is n into, okay, n into n time complexity. Okay, it exists for n into n times. Okay, it exists for n into n times. Okay, so it exists for n into n. So if I write here order, it is order of n into n, and that can be written as order of n square, right? Order of n square. And previously I told, ignore the numbers. Please, the numbers means the coefficient. If any number comes here, that you have to ignore. Okay, that you have to ignore. So I will be ignoring this 3, but this power, exponent should be not ignored. You have to write exponent n square only. You have to write n square only. So this is our time complexity. You can take a notes of this. Take a notes. Okay, so I will not stop here. I would like to expand this question, okay, by writing one for loop here. Let me write one for loop. So this for loop is outside the other for loops. So int I should be starting from 0, I should be less than n, I plus plus. Simply I will write this much only, like this. So now what is the time complexity, right? Watch here. So this for loop will take, this for loop will take how many times? This for loop will take n times. Okay, just a minute. Okay, this for loop will take n times. So total, if you are talking about the order here, it is a big O of, first one is n square. Then after n square, tell me, is it plus n or into n? It is plus n. Why? Because this for loop, whatever you are seeing, the last for loop is outside the other for loops, right? It is outside the other for loops. That is why, okay, that is why it is n square plus n. And now what do you have to do, right? When you have like something like this, should you leave it as it is? No, it should not leave it as it is. You have to see which n value has the highest, which this is called as a polynomial maybe, okay. So which polynomial has the highest what do you say, this has exponent, that you have to see. So you can see for the n value, this n value 2 is there, right? For this n value there is n to the power 1, right? That is n to the power 1. Now what you have to do is, when you have this kind of situation, you have to choose the n value which has the highest polynomial. So it is n square here, okay. N square you have to write. N to the power 1 you have to ignore, okay. So you can take a notes of this also, okay. Take a notes of this. Right. Okay. So I hope you have taken notes of this, Now let me give one what do you say, like homework, like a classwork kind of thing. So let's try to do it. Okay. So by now you should be able to tell, when you look at a program, you should be able to derive the time complexity, okay. So let's see here, if I had one equation like this, what will be the time complexity of that, okay. Let's see. So I'll choose a color. If I had a program which will execute for 3n square plus n plus n let's say 2n cube plus n plus 5, okay. So if you had something like this, what will be its time, like what will be its time complexity, I'll tell. So it's the order of 3n square plus n plus n. What is n plus n? That is 2n plus we have 2n cube plus 5. Now 5 is there, right? Don't think 5 is nothing but 5 into n to the power 0, because n to the power 0 is 1 and I can write it as n to the power 0. Now out of all these, which n has the highest degree? This is n square, but this is n cube, right? This is n cube. Now don't look at this number, okay. Don't see whether 3 is greater or 2 is greater, okay. Not that. You have to see the power here. You have to see the power. Which has highest power? This number. So this is what you have to select. Now after selecting this, that 2 you have to ignore, but only n cube you have to write. So this whole thing will be reduced to order of n cube. I hope this example is clear, okay. So when you have an equation like this is what you have to do in a simple way, okay. So let's take another example, right? So let's say 100n plus 50n square plus 5n cube plus 8n to the power 5, okay. If I write something like this, what do you have to see? It is the order of which has the highest degree. A number is there, you ignore the numbers, okay. Numbers all you have to ignore, but only you have to see the power, which has the highest power. N to the power 5, you write n to the power 5, done. That's it. This is our time complexity, okay. Is this clear? Okay. So I hope you have understood how to reduce that, right? Okay. So now let me give a last example from the beginning to the end, okay. Okay. So watch here. Let's imagine I have a for loop. Int I should start from 0, I is less than n, I plus plus. Inside this for loop, I have int j should start from 0, j is less than m, not n, m, j plus plus, okay. So here I will write some system.out print some statement, that's it, okay. Then I will be writing Okay, let me not write SOP, right? Let me write one more. Okay, so here again one more for loop. Int k should start from 0. K is less than t. Okay, k plus plus. Okay. Yes, this is enough. So what will be the time complexity of this, right? What will be the time complexity? It will be like this. Okay, let me, yeah, order of okay, so time complexity will be order of, don't you think it is n into, right? Because you have to multiply now. Whenever one for loop is inside another for loop, you have to multiply them, not add. When you have to add, when a for loop is outside a for loop. So here n into m into k, I have to write what? Order of n into m into k. This is the time complexity. You can't reduce much further. This is what only you have to write. So I hope that the concept about time complexity is clear. Okay, that's all you have to see. Then a question will come, right? Where is n log n? Where is log n? That we'll see in the future classes. Okay, that concept will come under advanced data structure and algorithm, because it comes under recursion and all. Okay, it comes under binary tree. It comes in the binary tree. So as of now, if you understand this much is enough. Now I want to give you a small overview of space complexity also, but it is not that important in programming, but I would like to tell you. Okay, I would like to tell you. So let's clear this. Imagine I have a main method, right? I have a main method. Okay, that is done. And this main method is calling one method called as display. Is calling a method called as display. Okay, fine. So now display method I have to write. So I'll write display method. And definitely it is something, maybe void, static void display. I will not write the signature there. In the display method, if I write SOP, simple SOP, tell me, did this program create a new variable? No. This display method, right? This display method, did it create a new variable? No. Right? So the space complexity is 1 here. Okay, the space complexity is also 1 only. I wanted to understand that. Okay, now imagine this display method. I have told here int n is equals to 5. Int n is equals to 5, right? Or let's say m, or any other variable, int m equal to 5. Now tell me, did I create a variable? Yes, I have created a variable, I agree. Okay, but tell me, whatever my input is, according to that, will this number change? Will the space change? No. I want you to understand that. Imagine that I execute this display. I execute this program million times. I executed it for million times. If I execute it for million times, in each time, the amount of memory it takes is constant. Agree or not? I will execute one time, m value is 5. I will execute the second time, m value is 5, means one variable is created for the m value. I will execute for the third time, again only one variable is created. I will execute for the fourth time, again only one variable is created. Agree or not? Yes, each and every time, how many variables are created? Only one variable is created. Again, don't you think it is a constant there? Which means you execute for how many times you want. You execute for whatever n value you want. The amount of memory it will create is only once. Yes, only once. Now, if I write something like this, okay, if I write string, what I'll tell, it accepts one string yes. Okay, I'll tell it accepts one string yes, and yes, if I write like this, now how much space it takes? Now I have to talk about the space complexity, right? So how much space it takes? Okay, so I'll write here, okay, whatever is in string yes, whatever is in string yes, you give it to whom? You give it to string t. I will tell something like this, I will tell something like this. Now I will tell here new string. Okay, how to create a string? String t equal to new string of yes, I will tell. Now you think and tell me, don't you think It is not a constant space it takes, because if your S value changes, your size of the T will change. Agree or not? If your S value is high, the T will be high. The length, the memory for the T will be small. If the S value changes, what do you say there? Then the T, the memory of T also changes. Agree or not? So as our S changes, right, our T also will change. Okay. Yes. So this is only the concept of space complexity. Now there is still some more things to understand here. Okay. There is still some more things to understand. So if I write here, see, there is something called as maybe you have heard, definitely you would have heard, big O notation, theta notation, and the lower bound, omega notation, right? You might have seen something like this, right? All these things I will be telling you. Okay. Just let this arrays complete. Okay. Let the arrays begin. Then I will be telling you about that. Okay. It's very simple. There is nothing to confuse here. Like this, simple by small point I will be telling each and every now and then. You might you'll be having clarity. Now see, you have to understand one thing. Okay, what you have to understand, your display method. This display method, tell me how many local variable does it have? How many local variable does it have? It has two local variables, right? String S and string T. String S and string T. Agree? Yes. So you should not worry about S, because whatever input is there, that you should not worry. Because to perform this computation, you need the help of string S. They will give one string S. Yes. But what is inside this display method is your logic, right? It is your logic. It is your efficiency. So that is what they will be seeing. Okay, that is what they will be seeing. So whatever you write, okay, whatever variables you create, on that you have to see how much memory it is taking. Okay. For example, if I am erasing all this, then okay, then let's imagine what I have to do is I have to okay. Let's imagine I have something like this. Okay, I have a string S, then I will accept one more string, I will accept string T, I will accept one more string, I will accept string Q, right? Okay. So tell me how many strings I am accepting. So string S is there, T is there, Q is there. Okay. But these are not considered in your space complexity. Why? Because sorry, it's not for loop. I'm very sorry. It's not for loop. It's that display method. Okay. It's the display method. Okay. Fine. See why these three are not considered. Why? Because if your display method has to execute, you have to use those three strings. You have to use those three strings, right? Yes. So those are the input. Like they are only giving the string, so no problem. Okay. But the variables which you are going to create, on that we have to see the time, the space complexity. Is it clear? Okay. So let's imagine. Yes, I hope I have taught you how to create an array, right? So if I write like this, int, I want a new memory. Okay. Why? To store integer type of data. How many data? Okay, I will tell. Okay, let's erase this. Do you know how to convert a string to char type array? Yes. How? S dot to char array. To char array I will take. Okay, I will write like this, and I will give it to AR of the char type, and it is one dimensional array. Okay. So now let's see what's the space complexity here. So don't you think as your string length changes, yes, changes, your array size will increase. Imagine your S is HAI. If your string is HAI, you will be getting one array of H character, A character, I character. Length is 3. What's the memory? Yes, don't think it took the length of the array is 3 now. Yes, memory is 3. If my string was umbrella, then my AR would have been UMB umbrella, right? UMB RELLA. So it depends directly on the S dot length, right? If your S dot length is 10, array length is 10. So linear, right? It's a linear growth. So we can tell, here it is the order of n. Again, it is the same order of S dot length, order of S dot length only. Okay, it's the order of S dot length. Is it clear? Or people will tell order of n, where you have to mention that n is nothing but S dot length. Okay. Now I know some of you are thinking, hey, you are writing order for time complexity also, for space complexity also. Yes. Why? I'll tell you why in later classes. What is this omega, big O and theta, right? What is all this? We'll be seeing. Very easy topic, we'll be seeing in the future. Okay. So I hope you have understood here. Okay. So let me create one more array, right? Char AR or BR, let's say BR, and here I will tell that is T dot 2 char array, 2 char array. Okay. So how many, right? How many memory will this program, will this line take? This line will take s dot length, or let's say n amount of memory. This line will take n amount of memory. Agree or not? Yes. The second line will take, tell me, is it necessary, is it compulsory to have s dot length and t dot length as same? Is it compulsory to have both the string as the same length? No. Your s dot length can be 100, t dot length can be 1000, right? Yes. So definitely this is my number n, means the size of the string s is n. Here the size of the string t is m. In that case, total how much memory it occupies? Don't you think it occupies n plus m memory? N plus m memory? Yes, it occupies n plus m memory. I want you to be clear in this. Okay, it occupies n memory for string s and separate one more array for the string t. So I hope you have understood. Okay, now let me write something like this. That is, here again not t dot length, but it is s dot length only. Okay, s dot 2 char array. So first also it is s dot 2 char array, second time also it is s dot 2 char array, but variables are different. Variables are different, which means a new array is created. So here it was the size of the string is n. Was the size of the string is n only. So now when you write n plus n, don't you think we can write it as order of 2n? And you know, whenever there is 2, we can write it as order of n only. Okay. Here space complexity you don't have to worry at all. Okay, because for us time is more important than space. Okay, for computer programming, yes, both are important, but most important is time. So I hope if you understood time efficiency, that is enough for you. Okay, space is not required. Okay. Okay. So in the future classes you will understand. Okay, let's imagine I will add to this example. Let's imagine I have told char cr is equals to new char of s dot length into s dot length. Okay. So if the s dot length was n, don't you think you are creating one memory of n into n? N into n is n square. So you are creating a new memory with n square. So the time complexity will change, n plus n square. And if you further bring it down, it is 2n plus n square. And you know from here what you have to do, right? Because you have to ignore this 2n, because n power is 1, here n square is there. So you have to write order of n square here. Is it clear? That's it. Okay. Okay. So if I erase all this, right? If I create a new memory, and if I explain it here. Okay. So as we have seen, let's say if I have int n, for memory display method is there. Display method. In this I am telling a int n, means I am accepting one number. Whatever number I am accepting, I'll try to store. I'll try to tell int c is equals to n, right? Whatever n value is inputted, that n value give to c. You tell me what is the space complexity of this program? What is the space complexity? Space complexity means if the n value is 5, if this n value, if the input for the method, right? If the input for the method, if this n value is 5, how much space it will take, versus if this n value is 100, how much space it will take, right? Yes, let's see here. If I take n value as 5 values given to c, 5 values given to c, tell me this is c, right? This is c. How many int means how many bytes? 4 bytes of memory is allocated. Okay, I'll write here in the case 1, right? I'll write here in the case 1, how many bytes? 4 bytes. Okay. I'll go to my case 2. In the case 2, I'll make n value as 100. Okay. What is n value? N value is 100. When my n value is 100, don't you think 100 is given to C? Can 100, can it be stored in C? Yes. Okay, it will store. What is the overall space taken by the program? It is 4 bytes only. It is 4 bytes only. Okay. Let me go to the case 3. Okay, here n value is 100. Here n value is 5. Let me tell n value is 1, maybe like this. Okay, 1 lakh. Okay, maybe 1 lakh. If I give 1 lakh to this n value, okay, what's the n value? 1 lakh. 1 lakh n value, I am giving it to C, right? Can C hold the 1 lakh? Yes, it can hold. If it can hold, only one variable is created. What is the memory of that? That is 4 byte only. So this is what I am trying to tell you. Are you noticing that whatever n value is, it is occupying the constant space? Constant space. That is why here we will tell it is the order of 1. Order of 1 means constant space. Okay, you can take a notes of this. Okay, you can take a notes. Okay. Now, okay, let me write one integer. Okay, AR is equals to new int of n. Okay, new int of n. Let's see. So let's see how many space it will create. What's my n value? My n value is 5. If my n value is 5, when this program executes, what will happen? One array is created of the size 5. One array is created of the size 5, right? Of the size 5. Agree or not? Yes, the size incremented. My n value will be, okay, let's see how many bytes, right? This is, tell me what type of array it is. Is it integer type array or float type array or string type array? Integer type array. Integer type array means what? Means each element in the array can store integer type. Means this can store integer type, this can store integer type, this can store integer, this can store integer, this can store integer. Which means this is 4 bytes, this is 4 bytes, 4 bytes, 4 bytes, 4 bytes. So totally 4 into 5 bytes. So 20 bytes of memory it took. Totally 20 bytes of memory it took when my n value was 5. Now let me see when my n value is 100, right? When my n value is 100, what will happen, right? If my n value is 100, don't you think here 5 into 4 happened, then 100 into 4 will happen. 100 into 4 is 400 byte memory will happen. Why? Because when your n value is 100, that n value is given to this new int of 100. And if new int of 100 means you want a new memory of n value 100. Clear? Means you got one big array whose memory will be very large, right? So as you can notice, when your n value is changing, right? When your n value is changing, right? When your n value is changing, your size of the array is also changing. So it is not a constant space, right? It is not a constant space. It is not like whatever n value you give, it will create a constant array size only. No, it is not constant array size. It is varying. That is why it is not a constant. So what you have to write? You have to write, can you see that it is n or n square? It is n. Means exponent, it is going in a linear way. So I can write it as order of n. Okay. So if the n value is 100, it will create an array of the size 100. If n value is 1000, it will create an array of the size 1000. So that's it. Okay. So this is our space complexity. I hope space complexity is also clear for you guys. Okay. So that's it. And by now and then no one is asking about this, but they will ask you, do you know or not? You simply tell yes, you know. And this much is enough to tell yes, you know. When we are solving this arrays concept, that time you will clearly understand what is theta, okay, and what is big O notation. All these things you will get to know. Okay. Okay. Now yes, I will erase this. So that's it. Okay. So that's it for today's class. Okay. So space complexity, time complexity, you have understood. And from tomorrow we will be starting with the arrays. Okay. The structure of arrays we will be seeing, and yes, how it works internally. Everything we will be seeing from tomorrow. Okay. Yes. So I really think that these videos, like individual 1.5 hour video, 1 hour video, it is you are understanding that each and everything. Okay. You are understanding that, and I hope that you are loving it. Okay, maybe sometimes I might go little speed. Okay, I'm sorry for that, but you do have an option to reduce it to 0.75x speed, or you can increase your speed to 1.5x also. So it depends on you. So I suggest you, whatever your speed is, you adjust according to that. Okay, and if you are liking these classes, okay, if you are thinking that yes, here logical teaching, right, I am teaching these logical skills in a more elaborate way than maybe other institutes or other online sources, then you can tell your friends to join this course here. Okay, you can tell their friends to simply attend the demo classes, and even after the demo classes they have to pay the fees on the 16th day, but from the 16th day till the 20th day they can get their fees back if they don't like it without any questions. Okay, so that is also there. And according to all the questions I have seen, right, programming questions, whatever I teach, based on that only they will ask. They will not ask other things. So 85% of the company, they ask whatever I do. Okay, they ask whatever I do in the class. Based on that only I have prepared this syllabus. Okay, I have prepared this syllabus, and the syllabus will keep on changing. Okay, it will keep on changing. So right now this is the syllabus where they will be asking questions like this. Okay, and see, if there is any problem from my side, please text me personally or in group. If you are feeling that I am going very speed, or if you are thinking that I am not teaching properly, please feel to communicate. Because see, if it was a one-to-one class, right, if you are in front of me, I could have read your face expression and immediately I could have reduced my speed. I could have done that tuning. But here, since it is online, I feel I face there is that problem. Okay, so that is I don't know in what level you guys are. I don't know who is, from what background they are watching this video. Okay, so when you are watching this video, sometimes your friend will call you and your concentration will go, and once your concentration will go, and it is very difficult to come back. But if it was in the class, I wouldn't have let your concentration to be gone anywhere. Okay, so that thing is there. So let's see. And those who wants to attend the offline classes, as soon as this corona ends, I think in the September it will end. September first week, I might start the classes in Bangalore. Okay, offline classes where programming, I'll be teaching with in front of you only. I think that will be more effective for you guys if you want. Okay, so yes, so I wish you all the best every day. Why? Because every day you should be able to solve new problems. Okay, go to HackerRank, solve new problems. All the best for that, and thank you for watching the video.